Hello, my dear students. In this lecture, we are going to see one previous year GATE numerical. This question was asked in GATE 2020. Basically, this question is based on conduction, convection, heat transfer through a cylinder. So let us understand the question. Water flows through a tube of 3 centimeter internal diameter and length 20 meter. So let us draw a tube through which water is flowing. Right. Let us say this is a tube. Now, in this tube, water is flowing, right? And my dear students, the diameter of tube, let us say D is the diameter of tube. Let's say this is the D diameter of tube, and diameter is given 3 centimeter. Internal diameter of tube is given 3 centimeter, which we can say 3 into 10 to the power minus 2 meter, and length of tube is also given 20 meter. In the first statement only they have given these values, right? And through this water is flowing. Let us say there is a water flowing through this tube, right? So if I draw this water, let us say the water is flowing through this tube like this, right? This is the water. Now my dear students, let us understand again question. The outside surface of the tube is heated electrically so that it is subjected to uniform heat flux circumferentially and axially. Now my dear students, the outside surface of the tube is heated uniformly so that it is subjected to uniform heat flux radially, that is, here they have mentioned circumferentially, means along this direction there is a uniform heat flux like this, right? And this heat flux is nothing but heat heat transfer per unit area, that is in watt per meter square, right? And as well as axially also the same heat flux will be there. Axially also the same flux will be there, right? Now again, let us understand. The mean inlet and exit temperature of the water are 10 degrees Celsius and 70 degrees Celsius. Now let us say here I am assuming the right side is inlet. Let us say from here water is entry, inlet, where the mean inlet temperature on this center line, we can say on this axis, let us draw this axis, right? On this axis, right, here the temperature of water at inlet, we can say Ti, the or temperature of water, let us say temperature of water at this point at inlet, temperature of water at inlet is 10 degrees Celsius, and at exit at this location temperature of water at exit is equal to 70 degrees Celsius, right? This is given. So here axially also the same heat flux will be there, Q, right? Same magnitude already given there. Now the mass flow rate of water is 720 kg per hour. Therefore here mass flow rate of water, which is 720 kg per hour. So let us convert into kg per second. Therefore it will be 720 divided by 3600 kg per second. This will be the mass flow rate of water. Then disregard the thermal resistance of the tube wall. Now here for this tube wall the thermal resistance offered is 0. The internal heat transfer coefficient is 1697 watt per meter square Kelvin. Now here it is a H value, that is for water convective heat transfer coefficient, that is 1697 watt per meter square Kelvin, right? Then take specific heat Cp of water 4.179 kilojoule per kg Kelvin. Here Cp value is also given for the water, which is nothing but 4.179 kilojoule per kg Kelvin, right? Then the question is the inner surface temperature at exit section of the tube is. Now here it is a exit, this location is a exit, right? At this exit location, what is the inner surface temperature of tube? That is wall temperature, inner wall temperature. Water temperature at the center line is given 70 degrees Celsius, right? Now let us understand here, my dear students, what will be the heat transfer here, right? My dear students, this question is a combination of conduction, convection as well as thermodynamics, right? So let us observe here. Now my dear students, here heat flux along axial direction as well as along circumferential direction is same, right? Now this heat flux along circumferential direction will be by conduction, because in this wall there will be a conduction. Therefore Q into, for this conduction the perpendicular area is a circumferential area, right? Therefore heat transfer, we can say the heat transfer over here, heat transfer. What are the modes of heat transfer? Let us observe here. right? Heat transfer is equal to, now along circumferential direction, this flux, heat flux, right, into area. Now area is circumferential along this direction, circumferential. Therefore, circumferential area is pi dl. This will be the heat transfer. Along axial direction, my dear students, along axial direction, because of temperature difference at this location, this is 70 degrees Celsius and this is the 10 degrees Celsius. Because of this temperature difference, in thermodynamics, you have studied that the heat transfer will be equal to mCpdT, that is mass of water, Cp of water into temperature difference, that is temperature of water at exit minus temperature of water at inlet. Because at exit it is a highest temperature 70 degrees Celsius and at inlet it is a 10 degrees Celsius. Heat always flows from high temperature to low temperature, right? This will be the thermodynamics, mCpdT, right? And this is a conduction, Q into area, right? And my dear students, as well as, right here, can I say the heat transfer rate for steady state, the heat transfer rate along circumferential direction is same. Now between the first layer, here I will draw with red color, for the first layer of the circumferential direction, this first layer of circumferential direction, there will be a conduction, right? And the conduction is this Q into pi dl area, right? But my dear students, between this wall is at temperature T wall, and the inside surface is at temperature of water, right? Can I say this wall temperature is T wall and inside surface is temperature of water? So my dear students, between this wall temperature, let us say here T wall and temperature of water, there will be a convection. 100% there will be a convection, right? Here there will be a convection, right? And my dear students, so here this wall temperature and temperature of water is unknown. This temperature of water is known at extreme ends, that is at inlet and at exit, right? Now they are asking what is the wall temperature at exit. Here question is the inner surface temperature at exit section, right? At exit section. Therefore at exit also, between this T wall and temperature of water at exit, there will be a convection only. There will be a convection only. This convection heat transfer, as per Newton's law of cooling, what is this convection heat transfer? It is HA, right? It is HA T wall minus T water at exit, right? Temperature difference, definitely wall temperature will be more than water temperature because heat is coming from here. Electrical, we are using electrical heater for here, right? Therefore it is HA T wall minus T infinity. And my dear students, for this convection, can I say this circumferential area is again subjected, means this area of convection is again circumferential area, that is pi dl. This area will be pi dl. And as well as for conduction, there is a circumferential area which is pi dl. So by equating these three equations, right, here instead of this A, I can write pi dl. Let us write here H, right? Here if I write H into pi dl, H into pi dl into temperature of wall which is required minus temperature of water at exit. Let us say this wall temperature, if I write surface temperature, because for water we have used temperature of water, right? My dear students, let's do correction. Here I will write temperature of surface, right? Here also I will write temperature of surface. Let us do this correction because already we have written temperature of water, W for water, right? Therefore it is, instead of temperature of wall, there is a temperature of surface, right? Therefore it is a temperature of surface minus temperature of water at exit, right? Let us equate these three equations and let us find the required value. So here, as temperature of surface is required, so equate the second and third equation that I have written with blue colors, right? If I equate them, then I will get the required result because all the values are given here. The mass flow rate of water is given, then Cp of water is given, then temperature of water at exit is 70 degrees Celsius, temperature of water at inlet is 10 degrees Celsius, H is given, convective transfer coefficient is also given, pi d diameter of the tube is also given, length of tube is also given, temperature of water at exit is 70 degrees Celsius. So let us equate them, right? So my dear students, here I am going to erase the question so that we will get sufficient space for the solution. Now, if I equate the second and third equation, right? So we will get the temperature of water. The equation is mass flow rate of water into Cp of water into temperature of water at exit minus temperature of water at inlet is equal to H into pi dl into temperature of surface minus temperature of water at exit, right? Therefore mass flow rate is 720 divided by 3600 into Cp of water is, let us use this Cp of water in joule per kg Kelvin, because here as other values, that is H we are using in watt per meter square Kelvin, so it is not, we are not using in kilowatt, therefore Cp we have to use in joule per kg Kelvin. Therefore Cp will be equal to 4179 joule per kg Kelvin. Therefore here Cp of water will be 4179 joule per kg Kelvin. Therefore into temperature of water at exit is 70 minus temperature of water at exit is 10 is equal to H is given 1697 into pi into diameter is given 3 into 10 to the power minus 2, right, into length is given 20, right, all the dimensions are given, into temperature of surface minus temperature of water at exit is 70, right. So my dear students, in this complete equation only temperature of water, temperature of surface of tube is unknown. So my dear students, let us solve this equation for temperature of surface. Then you will find that this temperature of surface will be equal to 85.67 degrees Celsius, because all temperatures we have kept in degrees Celsius. This answer will be in degrees Celsius. So my dear students, in this fill in the blanks, already they have mentioned the units in degrees Celsius. Therefore, you have to type 85.67 for getting 2 marks. Thank you, dear students. In next lecture, we will see one more numerical on this topic, which was asked in previous year GATE examination.